The night is the 8th of December, 1943, and across the flat fenland of eastern England, a thick, ghost-gray fog has rolled in from the North Sea and swallowed an entire bomber base whole. Somewhere above the cloud, a damaged Lancaster is circling with 2 engines gone and a crew that has already said its prayers. The runway below is invisible. The horizon is invisible. The world beyond the cockpit glass has simply ceased to exist. Then, without warning, 2 lines of flame erupt along the edges of the airfield, roaring upward in a wall of orange heat that begins to eat the fog itself. Within minutes, a corridor of clear air opens between the flames, a tunnel cut through weather that should have been impossible to defeat. The pilot sees the runway lights for the first time in 20 minutes and brings his crippled aircraft down safely onto English soil. He has just been saved by petrol, pipework, and a piece of British engineering so audacious that even some of the men who built it doubted it would ever work. This is the story of FIDO, the device that turned the weather itself into a weapon against the very thing that had always defeated air power most reliably: fog. Because while the Luftwaffe and the Allies built bigger bombs and faster fighters, Britain built something stranger and arguably more important. It built a way to burn the sky clear. To understand why this mattered, you have to understand what fog actually cost. From the earliest days of the Second World War, the Royal Air Force's Bomber Command was hemorrhaging aircraft not just to enemy flak and night fighters, but to its own airfields. British weather, damp, low pressure, and maritime, produced fog with a regularity that German meteorologists back home could scarcely imagine. Bombers would take off into clear skies, fly 8 or 9 hours to targets in the Ruhr or Berlin, survive anti-aircraft fire and interception, and then return home to find their own base smothered in fog so dense that pilots could not see their own wingtips, let alone a runway. Aircraft were diverted, sometimes hundreds of miles, often with fuel tanks running dry. Many simply crashed trying to land blind. Records compiled during the war suggested that weather, principally fog, was responsible for the loss of more aircraft and crews returning from operations than enemy action on certain nights, a statistic that horrified planners who had spent enormous resources training each man and building each aircraft. By some wartime estimates, hundreds of bombers were written off attempting landings in conditions no instrument of the era could safely penetrate. Existing solutions were pitiful. Smudge pots and oil drums burned at runway edges did almost nothing against thick fog. Radio beacons could guide an aircraft to the vicinity of an airfield but could not show a pilot where the ground actually was. Early radar-assisted landing systems existed only in prototype form and required skill and luck in equal measure. The brutal truth by 1942 was that the RAF possessed extraordinary striking power in the air, but no reliable way to bring that power home once the weather turned against it. Something had to dissolve fog itself, not just illuminate it, and nobody in the world had ever attempted such a thing on an operational scale. The problem looked quite reasonably unsolvable. The answer came from a partnership between the Petroleum Warfare Department and a small group of scientists working under Sir Donald Banks, with crucial early theoretical work from the Road Research Laboratory team, led by physicist William Hawthorne and a relatively obscure boffin named Stuart Pixton Phillips. Their initial idea, considered eccentric even within a wartime culture that had already invented bouncing bombs and floating concrete harbors, was that fog could be defeated not by avoiding it or seeing through it, but by setting it on fire from the ground. Fog forms when air becomes saturated with moisture, and the team reasoned that sufficient heat applied directly along the path of an aircraft's approach could evaporate that moisture in real time, carving a navigable corridor through cloud that sat barely above the ground. The system they developed, codenamed Fog Investigation and Dispersal Operations, or FIDO, was disarmingly simple in concept and fiendishly complicated in execution. Petrol, sometimes mixed with kerosene to control burn rate, was pumped through a network of perforated steel pipes laid along both sides of the runway, often running for over 1.5 miles at major bomber stations, When ignited, these pipes produced a continuous wall of flame standing several meters high, generating heat in the order of hundreds of degrees and burning through tens of thousands of liters of fuel an hour at full operation. The noise alone was described by ground crews as comparable to a jet engine at close range, a deep, continuous roar that could be heard for miles, while the heat radiating from the flame lines was intense enough that anyone standing too close for more than a few seconds risked serious burns. The fuel consumption was staggering for the era. A single hour of full FIDO operation at one major airfield could burn through more petrol than an entire squadron of fighters used in a typical sortie, an extravagance that only wartime priorities and the value of returning bomber crews could justify. The pipework itself was manufactured largely through requisitioned steel stock and assembled by Royal Engineers and civilian contractors working under blackout conditions, with installations eventually appearing at around 15 RAF stations across eastern England by the war's end, principally in Lincolnshire, Yorkshire, and East Anglia, the regions worst affected by coastal fog. Ignition was achieved by hand in the earliest systems, with airmen running along the pipe network with burning torches, a job nobody envied, before automated electric ignition was introduced to reduce both the danger and the delay. Production figures for the specialist valves, burners, and control equipment remain difficult to pin down precisely, much of the documentation having been classified at the time and only partially declassified decades later, but contemporary accounts suggest the system was operational, in some limited form, by the autumn of 1943. Its first major operational use came that winter, and accounts from veteran aircrew describe the experience in almost mystical terms. Returning bombers, navigating purely by dead reckoning and desperate radio fixes, would see nothing but black sky and gray murk until suddenly, ahead and below, a corridor of orange light would appear as if a door had been cut into the night itself. AF Gravelly in Huntingdonshire became one of the most heavily relied upon FIDO stations, and squadron records from bases using the system described nights when dozens of aircraft that would otherwise have been lost to fog alone were brought down safely through flame-lit corridors barely wide enough for a single aircraft at a time. The psychological effect on crews was, by several accounts, considerable, transforming what had been one of the most dreaded moments of any operation, the blind approach through fog with fuel gauges nearing empty, into something survivable. Precise figures for aircraft saved are difficult to state with total confidence, since records were not always centrally compiled and some accounts conflict, but post-war assessments by the RAF suggested the system was directly responsible for safely landing several thousand aircraft sorties across the war's final 2 years that would otherwise have faced diversion, crash landing, or total loss. If you're finding this as remarkable as I do, a quick subscribe genuinely helps more people discover stories like this one. It is worth asking what the other side had, and the honest answer is almost nothing comparable. The Luftwaffe experimented with various fog penetration aids, including a system of carbon arc searchlights intended to brighten runway approaches, but nothing approaching the scale or audacity of burning petrol along a mile of open pipe. Partly, this reflects different operational priorities. German bomber operations over Britain were conducted predominantly at night but over comparatively shorter distances, with less reliance on returning to bases plagued by the specific maritime fog patterns of the English coast. The Americans, flying daylight raids from many of the same English airfields the RAF used by night, occasionally benefited from British FIDO installations themselves, since United States Army Air Force's bomber groups shared several stations equipped with the system, though American development of independent fog clearance technology lagged considerably behind. Some post-war accounts suggest American observers were initially skeptical that burning a literal wall of fire beside a runway packed with fuel-laden bombers was a sound idea at all, a skepticism not entirely unreasonable given the obvious fire risk, though in practice serious accidents directly attributable to FIDO ignition appear to have been rare. The system's superiority lay less in any single technical breakthrough and more in Britain's willingness to commit extraordinary resources, fuel that was otherwise rationed with brutal severity, to solving a problem that other air forces simply tolerated as an unavoidable cost of war. The legacy of FIDO is curious because its triumph was quiet rather than spectacular. It never destroyed an enemy city or sank an enemy ship. The legacy of FIDO is curious because its triumph was quiet rather than spectacular. It never destroyed an enemy city or sank an enemy ship. Its achievement was entirely defensive, measured in air crew who came home rather than targets struck. Precise mortality figures it prevented remain genuinely uncertain, and historians are right to be cautious about overstating numbers drawn from incomplete wartime records, but the broader consensus among aviation historians is that the system saved a meaningful proportion of aircraft and crews that would otherwise have been lost to weather alone during the difficult winters of 1943 to 1945. Its influence persisted well beyond the war. The basic principle of thermal fog dispersal informed civilian aviation safety research for decades afterwards, even as later, less fuel-intensive methods eventually superseded it. A small number of FIDO pipe sections and control equipment survive today in aviation museums in Lincolnshire, including preserved fragments at sites connected to the old bomber stations. Quiet steel relics of a method so fuel-hungry it could only have existed under the strange economics of total war. Return, then, to that fog-bound night in December 1943, to the crippled Lancaster circling blind above an invisible England. What saved that aircraft was not radar, not a new engine, not a cleverer bomb. It was fire, deliberately set to defeat fog itself. Britain had looked at a problem nobody else had seriously tried to solve, the simple, ancient, indifferent fact of weather, and had answered it not with caution, but with petrol and steel and astonishing nerve. FIDO never won a battle in the way a Spitfire or a Lancaster's bomb load won a battle. It won something quieter and, in its own way, just as vital. It won the right of exhausted men to come home. The flames are long extinguished now, the pipework rusted or removed, the airfields turned back to farmland and silence. But somewhere in that history is a simple, stubborn truth worth remembering. Sometimes the most important weapon of war is not the one that destroys, but the one that brings people back alive.